Here is a matching type question. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us begin solving this step by step. We address each part using core concepts of nucleophilicity, basicity, and leaving group ability. A. Stronger nucleophile in aprotic solvent F or I. In aprotic solvents, example, DMSO, DMF, acetone, ions are not solvated by hydrogen bonding. Nucleophilicity therefore follows intrinsic electron density basicity. F is a harder, more electron-dense anion with higher charge density, making it a stronger nucleophile than I in aprotic media. Therefore, F. B. Stronger nucleophile in protic solvent F or I. In protic solvents, example, water, alcohols, smaller, more charge-dense anions are more heavily solvated by hydrogen bonding and thus less available to attack an electrophile. F is heavily solvated and effectively caged, while I is large and polarizable with low charge density, so it is poorly solvated and free to act as a nucleophile. Nucleophilicity in protic solvents follows polarizability, IF. Therefore, I. C. Stronger base F or I. Base strength is determined by the pKa of the conjugate acid. HF has pKa 3.2, while Hi has pKa -10. A stronger acid has a weaker conjugate base. Since HF is a much weaker acid than Hi, F is a much stronger base than I. Therefore, F. D. Stronger nucleophile in protic solvent, NH3 or NH2NH2, hydrazine. Both are neutral nitrogen nucleophiles. NH2NH2, hydrazine, is a stronger nucleophile than NH3 because the lone pair on the attacking nitrogen is made more electron-rich, more available. By the alpha effect, the adjacent nitrogen's lone pair raises the energy of the HOMO on the attacking nitrogen, enhancing its nucleophilicity. This alpha effect is independent of solvation considerations. Therefore, NH2NH2. E. Better leaving group CH3CuO or CH3SO3 methyl sulfonate. Leaving group ability correlates with the stability of the departing anion, i.e., ability to accommodate the negative charge. CH3SO3 methanesulfonate, mesylate, is derived from methanesulfonic acid, pK-1.9, a very strong acid, meaning the anion is extremely stable. CH3CuO acetate is derived from acetic acid, pK 4.75, a much weaker acid, so acetate is a poorer leaving group. The more stable, weaker base, anion is the better leaving group, CH3SO3 CH3CuO. Therefore, CH3SO3. Therefore, the correct answer is AF, BI, CF, D, NH2, NH2, E, CH3SO3. Therefore, the correct matching is A matches F, B matches I, C matches F, D matches NH2, NH2, E matches CH3SO3.